Again, welcome to Data Science and Big Data Analytics. This is ITS 836 course. In these lectures, we're going to discuss about using the R program for data science tasks. In our previous lecture, we discussed about the descriptive statistics techniques using the R, for example, finding the mean, median, mode, etc. In this lecture, we're going to discuss about how we can visualize our data using R. Here we're going to focus on the Gplot package. So again, the goal of the first part of this lecture is to get us up to speed up with the basic tools of data exploration as quickly as possible. Again, data exploration is the heart of looking at your data and also rapidly generating hypotheses, quickly testing them, and then repeating over and over again. Also, we can use the descriptive statistics techniques in exploring our data, understanding the attributes, the values, the relationship between the attributes, and also the values. Also, the goal of data exploration is to generate many promising lists that, again, we can later explore in more depth, especially finding the relationship between two or more of the attributes with a target variable or generating hypothesis. These are some of the few outcomes that we can again explore more detail using advanced machine learning algorithms. So visualization is a great place to start with our programming. And here we say because the payoff is so clear, you get to make elegant and also informative plots that help you understand data. Again, here, this is the process of our data science tasks. First, we get our data, so we import the data from any source. Then we do the tidying and transform. Tidying and transform is the data preparation process, how we can normalize our data, how we can, if we need to discretize our attributes, etc. So that's the process. So the first processing again, preparing the data for modeling. But before modeling, it will be a good idea to visualize our data. By visualizing our data, we may likely see the patterns in our values in the data. So after visualization of the data, then we again apply the machine learning algorithm or data mining algorithm to model our data. Then later we communicate our result. So this process is the same as the previous slide we talked about, data analytics life cycle. First, we generate our data, or in this case, we import our data. Then we perform the data preparation, which is the tidying and transform, or data wrangling. Then later, we visualize our data, see if we can find some pattern in the data. Then from there, we again use learning algorithm to model our data. Then we communicate our result with the management or the stakeholders of the project. So in data visualization, we will delve into visualization, learning the basic structure of a Gplot2 plot. Again, Gplot2 is a R package that make it possible for us to, again, plot advanced graphs with nice features. And also the powerful techniques for turning data into plots. So visualization alone is typically not enough. So in data transformation, we will learn the key verbs that allow us to select important variables, filter out key observations, create new variables, and compute summaries. Finally, again, in exploratory data analysis, we will combine visualization and transformation with our curiosity to ask and also answer interesting questions about the data. So the prerequisites here, we need, in order to do a data science task, the first thing we need is our data set. So this lecture will focus on Gplot 2, which is one of the core members of the Tidyverse. Again, Tidyverse comes with the R program, or the R package, it's R package. So in order to access the data set, we need to again install our Tidyverse. If a Tidyverse is installed already, then what we need to do here is to load the Tidyverse. So here we say to access the data set, help pages and functions that we use in this lecture, load the Tidyverse by running this code. So again, in the command prompt in your R program, either you are using the R Studio or the R command prompt, again, type in the library Tidyverse. And we know this code library here means we are loading the package Tidyverse. Now, if you run this code Tidyverse, library Tidyverse, and you have an error, then most likely we have not yet installed the Tidyverse. So that will take us to the next slide here. So this means we have to install our Tidyverse first before we load it. So the command will be install.packages Tidyverse, or if you are using the R Studio, again, you can use the menu buttons to load both load and install the package Tidyverse. So here we say you only need to install a package once, but anytime we start the program, the R, we always have to reload it. So when I install it once in my R program with the R Studio, it's there always. But anytime I want to use it, when I log into the system and I want to use it, I have to load it first. So loading is using the library function. The argument is the package name Tidyverse. Or if you are using the R Studio again, we can use the menu bar. So if we need to be explicit about where a function or data set comes from, again here we will use the special form package, then the function. So the keyword package, 2 column, then the function name. So this is an example here, Gplot2. That's our package. And we are using the function Gplot. So this tells you explicitly that we are using the Gplot function from the Gplot2 package. So again, the syntax is the package name first, then double column, then the function name. So example here, the package name is Gplot2, and the function to plot our graph is Gplot. So this is the first step for the hands-on. Here we are assuming again that we have done the 2-step. Again, this slides or lectures is a hands-on using our program. So we do the 2-step. If you have not yet installed your Tidyverse, install it first using the command install.package. Then after that, we use the library function to load it. The next step now, we want to analyze our programs, our data. So here we say, let's use our first graph to answer a question. This is the question we want to answer when we analyze our data. Do cars with big engines use more fuel than cars with small engines? Most likely we know this answer already. Cars with big engines normally consume more fuel than cars with small engines. But let's do a practice here with the R program. We also have the data set. So what does the relationship between engine size and also the fuel efficiency look like? Is it positive, negative, linear, or non-linear? So we know if it's positive or negative. If it's positive means if one relationship, one attribute increase, the other also will increase. So our relationship here is the engine size and the fuel efficiency. If the engine size increase and the fuel also increase, we have a positive relationship. If engine size is increasing but the fuel efficiency is going down, then we have negative. And if it's linear, the linear can be a linear positive or linear negative. Just means that the graph is a straight line. That means it's increasing in constant order. And non-linear can be increasing exponentially or not exponentially, logarithmic, can be any non-linear function. So again, the data we're going to use is called the MPG data frame. So here we say we can test our answer with the MPG data frame found in Gplot2 package, also known as Gplot2 MPG, double colon MPG. So a data frame is a rectangular collection of variables in the columns and also observations in the row. So it's more or less a table. Table consists of rows and columns. The column will be our attributes and the rows will be our record. So a data frame, again, is a rectangular collection of variables. It's more or less like a matrix also. So here we say we have our data set. MPG contains observations collected by US Environmental Protection Agency on 38 models of cars. So this is our data set. We can see that in this data set, we show up to 6 observations or records. The rows are 6. And here we are saying that up to 228 more rows. So this means we have 222 records. Then we have our attributes. So for example, the first attribute is the manufacturer model. And the first few cars we see here, they are all Audi. So the first 6 cars here, they are Audi. Then also we see this phrase again, and also the year. This will be the size, the year of the car. And also the cylinder, CYL, that would give us the number of cylinders. We know we have 4, 6. Most big cars have 8. Then we have the transmission is 2 type, either auto or manual. And the list keep going. So again, these are our attributes, and our rows again are the records. So here we say the DISPL is the car's engine size in liters. Then HWY is the car's fuel efficiency on the highway. And I think this is based on our question. Now we can see the record we have here. We have more than 2 attributes. At least we have somewhere around 3, 6, 8 attributes. But based on the question given, here the question said, do cars with big engine use more fuel than cars with small engines? Also, what does the relationship between engine size and the fuel efficiency look like? So this means if I'm doing this analysis, my main concern will be the car engine size column and also HWY, which is the efficiency, the fuel efficiency used. Our goal is to find the relationship between fuel efficiency and the car engine size. So first we decided to plot this, our data in PG. So we know our function name is Gplot. We say the data is MPG. Then we have geom point. We will soon discuss about what we mean by AES, which is the aesthetic. And this is one of the attributes of the or the characteristics of the graph. So for example, here we say X, we are trying to locate that the X, which will be horizontal, should be the size of the car, and Y, which is vertical, should be the fuel efficiency in highway. So here we say the plot shows a negative relationship between the engine size and also the fuel efficiency. In other words, cars with big engines use more fuel. And then we say, does this confirm or refute our hypothesis about fuel efficiency and also engine size? If again, confirm or refute. And with Gplot 2, we always begin a plot with the function Gplot. And Gplot function creates a coordinate system that again you can add layers to. So the first argument of Gplot is the data set to use in the graph. So we have Gplot data is MPG. This will create an empty graph, but it's not very interesting, so I'm not going to show it here for now. Now you complete your graph by adding one or more layers to Gplot. So the function geom point will add a layer of points to your plot. So this is what I want to explain now. We can see if I have only Gplot, data is MPG, it's not going to show anything. But now we want to add layers to it. So we use the graph, we use the geom point, then mapping the X and Y axis using a aesthetic function. So here we say again, we complete our graph by adding one or more layers to Gplot function. And also the function geom point will add a layer of points to your plot, which will create a scatter plot. So Gplot 2 comes with many geom functions that each had a different types of layer to a plot. And we are going to learn a whole bunch of them throughout this chapter. So each geom function in Gplot 2 takes a mapping argument. And this will define how variables in our data set are mapped to visual properties. So again, the geom function in Gplot 2 package will take an argument of mapping. We saw the mapping argument, which always pair with the aesthetic function. And the X and Y argument of aesthetic will specify which variable to map to X and which variable to map to Y. So Gplot 2 looks for the map variables in the data argument. So we can see here we have the geom point mapping, then aesthetic, we say the size of the engine should be X-axis, and also the fuel efficiency on highway should be Y-axis or vertical. Anytime we say X, we mean horizontal, Y means vertical. So let's turn this code into a reusable template for making graphs with Gplot 2. So here, to make a graph or replace the bracketed section in the code below with a data set, a geom function or a collection of mappings. So we have the Gplot, the data equal to data. Then we have the geom function. The mapping will be the aesthetic mappings. So again, the rest of this session lecture will show us how to complete and also extend this template to make different types of graph. So this is our template. Always we start with the Gplot, which is the function. Then we specify the data we have using data argument. Now, if we want to map, we can also use the mapping. The static function here with our mapping is what will be y, the vertical line, and what will be the horizontal. So in the plot below, one group of points which is highlighted in red, we can see this section highlighted in red, seem to fall outside of the linear trend. We can see that most of the linear trend is here. So these cards may have a higher marriage than you might expect. Now, how can we explain that? Maybe we can say those red lights here. Let's say this chart here is for a car, different car sizes. But we can say, okay, this is a box or a tractor or some heavy duty cars. And again, they are very powerful, so they consume a lot of energy or the fuel. Or we may say these are very small cars, motorcycles, and they commit very, very small fuel comparing to majority of the cars we have, which is 4 cylinders. And also the power is maybe 3 times or 4 times more than the small cars. So that's what we say here. We say let's hypothesize that the cars are hybrids. So that will be a different car comparing to the rest. So one way to test this hypothesis is to look at the class value for each car. Now the class variables of the MPG dataset will classify cars into groups such as the compact, mid-size, and SUV. Now, if the outlying points are hybrids, they should be classified as compact cars or perhaps subcompact cars. Again, we should keep in mind that this data was collected before the hybrid trucks and SUVs became popular. Now, we can add a third variable class to a two-dimensional scatter plot by mapping it to an aesthetic again function. And we say an aesthetic is a visual property of the objects in your plot. So visual property of the object. Now we can see some dots we have. Some are black, some are red. And that's the visual, again, property of the object. Can be the color also. And also aesthetics include things like the size, the shape, or the color of your points, as we mentioned earlier. And you can display a point like the one below in different ways. And that's in our next slide. These different ways by changing the values of its aesthetic properties. Since we already used the word value to describe data, now let us use the word level to describe the aesthetic properties. So here we change the levels of a point size, the shape, the color, to make the point small or triangular or blue. Now we can convey information about the data by mapping the aesthetics in our plot to the variables in our data set. So for example, you can map the colors of your points to the class variables to reveal the class of each car. So this is the example here. So we can again see our Gplot. We are using the MPG data. Then we have our geom point. We're mapping the X to be the size of the engine. Y is the fuel efficiency on highway. And this time we include the color, which the color will depend on the class. So here we can see we have different colors for different points. Again, depends on the class of the car. For example, green cars are normally mid-size. Minivans are light green. We have red to be the two-seater cars. Pink SUV. So again, so far, this is the only two commands we are focused on. First, as we said, again, you have to either load the tied verse. If the tied verse is not installed, then the first thing you have to install it, then you load it. Then in the tied verse, we have all these again functions and also a data set. And we can see the syntax for plotting. Again, we use the Gplot function, taking the argument of the data name. So the data is MPG. Then we use geopoint to map our X and Y values and any other properties. So we have mapping. Here we want to do aesthetic. So we say horizontal should be the size of the engine, which is the DISPL, and the Y should be the highway car efficiency consumption. Then this time we have a third color, which is the class. So to map an aesthetic to a variable, first we need to associate the name of the aesthetic to the name of the variable that we are matching to into AES function, again, aesthetic function. Then ggplot2 will automatically assign a unique level of the aesthetic or the unique color to each unique value of the variable. And here we see a process known as scaling. So ggplot2 package will also have a legend that display which level correspond to which values. And the colors reveal that many of the unusual points are two-seater cars. Again, based on our color here. You can see two-seater cars are red. So most of the red or the points that is not in the model are two-seater cars. We say these cars don't seem like hybrid and are, in fact, sports cars. Sports cars have a large engine like a SUV. So again, this is our aesthetic mapping. As we see in the previous example, we map class to the color aesthetic, but we could have mapped the class also to the size aesthetic in the same way. So in this case, the exact size of each point will reveal its class affiliation. So I have ggplot data is MPG. We use the geopoint and then mapping the aesthetic. We have our X, Y, and also the size, which is the class. So there's a warning here saying using size for a discrete variable is not advised. So this will be our output. We can see the two-seater again. Here now, the result depends on the size of the circle. So we can see that SUV is the biggest circle. And also we have subcompact. So also we could have mapped class to the alpha aesthetic, which controls transparency of the points, or to the shape aesthetic, which control the shape of the points. Now, what happened to the SUVs? ggplot will only use 6 shapes at a time. So by default, additional groups will be unplotted or will go as no plotting. We don't plot it because again, ggplot only uses 6 shapes at a time. So let's go to the, if for example, 1, 2, 3, 4, 5, 6. So here we have 7. 1 will be unplotted because again, ggplot2 use again 6 shape at a time. So for each aesthetic, we are going to use the AES, which stand for again the aesthetic, to associate the name of the aesthetic with a variable to display. So here the AES function gathers together each of the aesthetic mappings used by layer and also passes them to the layers mapping argument. So here we have the Gplot, data MPG, the geom point, we map our aesthetic. The S is our DISPL, which is the size of the car. Y is HWY, which is again, is our fuel efficiency on the highway. So using the AES, we were able to specify our horizontal value attribute, then our vertical, and our alpha will be a class. Now also we have Gplot data MPG, geopoint. We have the aesthetic, S equal to DISPL, Y the same, and then the shape. Here also we can set the aesthetic properties of our geom manual. For example, we can make all of them points in our blue. So here we are making all of the points in the blue, plot blue. So we have Gplot data MPG. Then Gplot mapping AES aesthetic. Now you can see that we specify our X and Y. Then we assign blue to again. So here we can see our dot blue again. The argument is color is blue. We specify what is the X and what is the Y, vertical. So here the color doesn't convey information about the variable. This is just again to make our plot more visualized, more nicer, or more attractive. So, and the type of graphs we show doesn't really relate to the information about any variable, but only changes the appearance of the plot again, just to make it look nice. So to set an aesthetic manually, we can set the aesthetic by name as an argument of geom function. That is, it goes outside of AES. So again, the name of a color is a character string, the size of the point in mm, and also the shape of a point as a number as shown. So you can see different shapes. R has a 25 built-in shapes that are identified by numbers. And there are some semi-duplicates. For example, 0, 15, and 22 are all squares. Now the difference comes from the interaction of the color and the fill aesthetics. Also the hollow shapes from 0 to 14 have a border determined by the color. So that will be the conclusion of this lecture. Again, this is a very short lecture on visualization of data using R, and it's a hands-on lectures which focus again on the Gplot2 package with the Gplot function. And one of the function arguments can be the aesthetic, AES, and normally we use AES to simplify or to map our X and Y axis, that is the horizontal and vertical axis. Now we can change, as we saw example, changing the color or the appearance of the graph, if it's a dot, etc. Using the AES also. So this will be our exercise. Again, it's just a hands-on exercise. So here we again tell us to run the Gplot data, the same data we use in the example MPG. And now we are asking the question, how many rows are in the MPG? How many columns? What do you see? Then what does the DRV variable describe? Again, just by looking at, you look the data and you see the attributes and it explains. You have to explain. So read the help for MPG if you think it's difficult. Again, you type in R, again, until we went through this in our first lecture. In R, if I want to type in the command prompt for help, I will start with a question mark and whatever help I need. I can have question mark print and no space between. Or if you are using the studio, that's the R studio, use the menu for help also. Then we're going to make a scatter plot, choosing two fields, that will be the HWY with the cylinder. So here we want to know if there's any relationship between fuel consumption and the number of cylinders of the car. Previously, we did a relationship between the fuel consumption on highway with what? The size of the cars. And this time we are going to use a cylinder. Also, what happens if you make a scatter plot of class versus DRV? And now we say, why is the plot not useful? So that's first question. Second, what goes wrong? What's gone wrong with this code? Why are the points not blue? So we have a code here, and the code generates this graph. When we look at the aesthetic, we look the command for color is blue. So why, if it's blue here, why the graph is not blue, but rather red? So again, that's exercise. Give it a try. Then, which variable in MPG are categorical? We discussed this in a previous class. For example, a categorical data will be a qualitative data, a data that we cannot do no arithmetic operation on. So which variables are continuous? Continuous will be a data that is based on measurement. So let's say height, weight, etc. So we can do a calculations on continuous arithmetic operation. So here they say the hint, we should type question mark MPG to read the documentation for the data set. And again, the documentation will see the answer. Again, this is just a practice for us to get used to understanding the basic concept of data analysis, or in this case, data visualization using the R program. So the answers are there somewhere, but again, it's just a practice to go through. Now, how can you see the information when you run MPG? Now, map a continuous variable to color, size, and shape. How does this aesthetics behave differently for categorical versus continuous variable? So remember, color is categorical, size is continuous, shape categorical. Now, what happens if you map the same variable to multiple aesthetics? And what does the stroke aesthetic do? And what shape does it look with? What shape does it work with? They give us an hint there. You use the help. Then what happens if you map an aesthetic to something other than a variable name, like AES color equal to the size the size of the car less than 5. So that will be our conclusion for these lectures. Again, this lecture is the main concept is going through the basic concept of visualization of data using R. And this lecture again may help us for our hands-on project in our course. So again, wish everybody the best. Thank you.